Good morning, all of you. I'm going to start with the next topic as I told you in the last lecture. Uh, Firstly, I'm sharing the next topic here. I, as I discussed about all things about UML, now I am moving to the next topic, process of OOM. As I discussed in last lecture, something I explained about OOM. OOM is object oriented methodology, methods, the object oriented modeling. The modeling passes through the following process. First, OO system analysis, object oriented system analysis. And second, system design. And third, object design. And fourth, object oriented programming. These four uh, phases by which object-oriented modeling is passes through to create a model for a particular system. Now I am discussing here about OO system analysis. OO means object-oriented system analysis. In this step, a statement of the problem is formulated and a model is built by the analyst in encouraging real world situation. This phase shows the important properties associated with the situation. Actually, the analysis model is a precise abstraction and agreement on how the desired system must be developed. You can say that there you can say that here the objective is to provide a model that can be understood and criticized by any application experts in the area, whether the expert is a programmer or not. This in this phase basically expert in the area, whether the expert is a programmer or not. Moving to the next, system design. In this step, the complete system architecture is designed. This is the stage where the whole system is divided into subsystems based on the both the system analyst model and the proposed architecture of the system. As described here, in this system design, the whole system is divided into blocks, and these blocks is based on the system analysis model and proposed architecture of the system. Moving to the next, object design. In this step, a decision model is developed based on the analysis model, which is already developed in the earlier phase of development. The object design decides the data structures and algorithms needed to implement each of the classes in the system with the help of implementation details given in the analysis model. Moving to the next, object-oriented programming. In this stage, the final implementation of classes and relationships developed during object design take place. A particular programming language, database, or hardware implementation. Actual implementation should be done using software engineering practice. This help to develop a flexible and extendable system. Now I am explaining four different phases from which a object oriented model goes and develop the required model according to the requirement, according to the system development. These are the phases on which a object oriented model goes and develop a required model. Now I am moving to the next topic, which is related to the concept of UML modeling. It's very important because without a concept modeling, we cannot develop any unified modeling language model which is related to any software system or non-software system. Here I am just concerning about the concept of model of the UML. Here here I am showing one architecture of conceptual model of UML. You can easily, firstly you note down this architecture, and after that when I am explaining it, you can just see that particular things and pick out. Firstly I will explain from the start. To understand conceptual model of UML, first we need to clarify what is a conceptual model and why a conceptual model is at all required. First point, a conceptual model can be defined as a model which is made of concepts and their relationship. Second, a conceptual model is the first step before drawing a UML diagram. It helps to understand the entities in the real world and how they interact with each other. These two main points. First one is defined as model which is made of concept and their relationship. And second one is drawing a UML diagram. It helps to understand the entities in the real world and how they interact with each other. As UML describes the real-time system, it is very important to make a conceptual model and then proceed gradually. Conceptual model of UML can be mastered by learning the following three major elements. These three major elements are very important to discuss about the concept of UML models. First one is UML building blocks. Second, rules to connect the building blocks. And third, common mechanism of UML. Now I am moving to the first one. As I mentioned in the architecture, the three main blocks. First one is, as I earlier said, I again repeat that things from the architecture. First one is building blocks. Second one is rule to connect the building blocks, and third one is common mechanism. Here again I am starting with the building blocks. The vocabulary of the UML encompasses three kind of building blocks. First is things, second is relationship, and third one is diagrams. Again, this contents of elements which is in the building blocks is further classified. Firstly, I am going with the things in UML. Here I am mentioning UML include four kinds of things. One is structural things, second one is behavioral things, and fourth one is grouping things, and fourth one is annotational things. Now I'm starting with the first structural things. Structural things are the nouns of UML models. These are the mostly static part of model, representing elements that are the earlier conceptual or physical. There are 7 structural things in UML. In other words, these are the mostly static parts of a model, representing elements that are either conceptual or physical. Now moving to the first structural thing is class. A class is a description of a set of objects. that share the same attributes, operations, relationships, and semantics. A class implements one or more interfaces. Graphically, a class is represented as a rectangle, usually include its name, class name, attributes list, and operation list. Moving to the next structural thing, interface. Interface is a collection of operations that specify a service of a class or component. An interface therefore describes the externally visible behavior of that element. An interface might represent the complete behavior of a class or component or only a part of that behavior. And this will be represented graphically is represented as circle or a class symbol typed with interface. Now moving to the next structural thing, collaboration. A collaboration is the collection of interactions among objects to achieve a goal. Graphically, collaboration is represented as dashed ellipse. Dashed ellipse. A collaboration can be collection of class or other elements. To provide some cooperative behavior, that's bigger than the sum of all the elements. Now, next, moving to the next structural thing, use case. A use case is a description of set of sequence. A use case is description of a set of sequence of action that a system performs. And observe result of a value to a particular actor. A use case is used to structure the behavioral things in a model. A use case is realized by collaboration. Graphical, a use case is represented as an ellipse with solid lines, usually include only its name. As I am here mentioning, a use case is a collection of action defining the interaction between a role and the system. Graphically, use case is represented as a solid ellipse with its name written inside or below the ellipse. Moving to the next structural things, active class. A class whose objects can initiate its own flow of control and work in parallel with the other object. Active class is a class whose object own one or more process or threads and therefore can initiate control activity. An activity class is an active class is just like a class, except that its objects represent elements whose behavior is concurrent with other elements. Graphically, an active class is represent like represented as a rectangle with thick borders. Moving to the next, component. A component is a physical and replicable part of a system. A component is a physical and replicable part of a system that conforms to provides the realization of a set of interfaces in a system. You will encounter different kinds of deployment components, such as component of Java, Beans, as well as components that are artifacts of the development process, such as source code file. A component typically represented the physical packaging of otherwise logical elements such as class, interface, and collaborations. Graphically, a component is represented as a rectangle with tabs, usually including only its name. Moving to the next, node. A node is a physical element that exists at runtime. A node is a physical element that exists at a runtime and represent a computational resource. Graphically, node is represented as a cube. Examples of node are PCs, laptops, smartphones, or any embedded system. We can explain more about node. Generally have at least one memory and often processing capability. A set of components may reside on a node and may also migrate from node to node. Now moving to the next thing, behavioral thing. As we discussed the total four kind of things, here I'm explaining first structural, and now I'm moving to the next behavioral things in the building block of the UML. Now behavioral things, it represents the dynamic aspects of a UML models. Behavior of a UML models can be modeled as interactions or as a sequence of state changing. There are two primary kind of behavioral things. First, interaction. Second, state machine. Now I am discussing about interaction. A interaction is a behavior that comprises a set of messages exchanged among a set of objects within a particular context to accomplish a specific purpose. A behavior made up of a set of messages exchanged among a set of objects to perform a particular task. An interaction involves a number of other elements including message, action, sequence, and links. Graphically, a message is represented as a direct line, almost always including the name of its operation. A message is represented as a solid arrow. Below, in an example of interaction, represent a phone conversation. Here, the arrow will show the interaction of two phases from seller and phone system and receiver. These arrows are showing the interaction of the different phase. Here, three phases. One is seller, second one is caller, second one is phone system, and third is receiver. What are the interaction between these three persons, which will be shown by these arrows? As you see, pick up and dial the phone, and dial tone, dial number. These are the interaction shows in the form of arrow. I'm moving to the next, state machine, a behavior that specifies the sequences of states an object or interaction goes through during its lifetime in response to events. A behavior that specifies the sequence of states an object or interact goes through during its lifetime in response to event. A state is represented as a rectangle with rounded corners. Below an example of a state machine representing the states of the phone system. As I mentioned here, you can see the state machine is a behavior that specifies the sequence of states an object or an interaction goes through during its lifetime in response to event together with its responses to those events. The behavior of an individual class or a collaboration of classes may be specified with a state machine. A state machine involves a number of other elements, including states, transitions, events, and activities. Graphically, a state is represented as a rounded rectangle, usually include its name and its substates. As mentioned in this example, these are the states which are showing here. These are the rectangular shapes: dial tone, dialing, connected, invalid number, busy tone, ringing. These are the different state which show the behavior of the model. Moving to the next is a group things. As here I am mentioning group things, element which are used for organizing related things and relationship in models. Group things are the organizational part of UML models. These are the boxes into which a model can be decomposed. In all, there is one primary kind of grouping things, namely package. Here we can again classify group things into package, and into the package a general purpose mechanism for organizing elements into groups. Graphically, package is represented as a tabbed folder. When the diagrams become large and clustered, related are grouped into a package so that the diagram can become less complex and easy to understand. Now moving to the annotation thing. A notational thing. A notational thing are the explanatory part of UML models. These are the comments you may apply to describe, illuminate, and remark about any element in a model. There is one primary kind of annotational thing called a note. A note is simply a symbol for rendering constraints and components attached to an element or a collection of elements. Graphically, a note is presented as rectangle with a dialog and corner together with a textual or graphical comment. Now it's complete. I'm showing the next topic in the next lecture. Thank you.